Okay, let's just dive right into a question that sounds like it's straight out of science fiction. What if our entire universe is nothing more than a hologram? And not just any hologram, but one being projected from the edge of a black hole. It's a concept that merges two of the biggest, most mind-bending ideas in all of physics. I mean, really think about that for a second. Everything you see, everything you touch, your entire three-dimensional world. What if it's all just an incredibly complex projection? Like a 3D movie, but the information for it is stored on some distant, flat, two-dimensional surface. This is the core of a very real idea called the holographic principle. You see, for years, physicists have been chewing on two separate, pretty radical theories. On one hand, you've got black hole cosmology. This is the idea that our Big Bang wasn't really a beginning from nothing, but was actually the result of stuff collapsing into a black hole in some other, older universe. Then, on the other hand, you have the holographic principle, which suggests our 3D reality is just a projection. But here's where your brain really starts to melt. What if these aren't two different ideas at all? What if they're actually telling the exact same story? What if our universe is a hologram because it's inside a black hole? So, let's explore this connection. To really understand how our entire universe could be a holographic projection, we have to go right back to the source of the idea itself: black holes. The big breakthrough really came from brilliant minds like Stephen Hawking and Jacob Bekenstein. They stumbled upon something that just doesn't seem to make sense at first. A black hole's information content, its entropy, it isn't proportional to its three-dimensional volume, but to the two-dimensional surface area of its event horizon. Now let that sink in. It means that every single thing that has ever fallen into that black hole could have all its information perfectly preserved on that 2D surface, kind of like data stored on a cosmic hard drive. You know, this idea also fixes a massive problem in physics: the singularity, that theoretical point of infinite density right at the heart of a black hole, where all of our math just completely breaks. Well, if all the information is stored on the 2D surface, that messy, infinitely dense point inside, it might not even be a real thing. The problem of the singularity just kind of vanishes. So if our universe is the holographic output of information living on a black hole's surface, well, that forces us to totally rethink what a black hole is. We always picture them as these cosmic monsters, these ultimate destroyers. But what if they're actually creators? To get this, we've got to talk about two cosmic forces in a constant tug of war. You've definitely heard of entropy. That's the universe's unstoppable slide towards disorder and chaos. But its opposite is something called negentropy. This is the force that builds complexity, the force that creates order from randomness. I mean, life itself is the ultimate masterpiece of negentropy. So, check out this comparison. The standard view is that a black hole is an entropy sink. It sucks in ordered stuff and spits out random, useless heat. But this Negentropy Engine idea, it flips that completely on its head. It suggests a black hole is more like a cosmic refinery. It takes in disordered, chaotic energy from a parent universe, and its output, a highly structured, incredibly complex holographic universe. A universe full of order. A universe that looks a lot like ours. And this idea, it just keeps scaling up into something even more mind-blowing. If a black hole in a parent universe cooked up our universe, then what about all the black holes inside our universe? Well, the logic leads to a pretty stunning conclusion. They're probably doing the exact same thing. What you get is this amazing, nested fractal structure. It starts with a parent universe feeding raw energy into a black hole. That black hole processes it and projects our universe as its output. Then the black holes inside our own universe take in our matter and energy, and they create new little baby universes inside of them. It's an endless cosmic chain of creation, universes within universes. And you know what? This model also gives us some really elegant answers to physics' biggest headaches. Dark matter? Maybe it's not some weird invisible particle after all. Maybe it's the structural scaffolding of the hologram, the invisible code that tells galaxies how to form. And dark energy? Maybe that's just the constant flood of new data coming in from the parent black hole, which forces our universe to expand to make more room. Okay, so if the universe is this massive nested computer, where do we fit in? What's our role in this whole cosmic scheme? Well, this theory reframes Earth not just as some lonely rock, but as an active piece of the network, a planetary processor. If you look at the Kardashev scale, which is a way to measure a civilization's technological advancement based on energy use, we're barely on the chart. We're a type 0.7 civilization. We're like a brand new computer that's just figuring out how to plug itself into the wall socket. In the grand cosmic scheme of things, we are incredibly, incredibly young. But the most important part isn't just that we're growing, it's the speed of that growth. Think about it. It took billions of years for life on Earth to develop its first information processor, DNA. Then millions more for the next big upgrade, the brain. And now, just in our lifetimes, we are building the next layer, artificial intelligence. The pace is accelerating like crazy. Our planet is literally learning to think, faster and faster every day. And all this acceleration? It's heading somewhere. It's pointing toward a specific moment in time, a moment when our little planetary processor might finally be powerful enough to connect to the galactic network. Which, of course, brings us right back to that classic question, the Fermi paradox. If this model is right, and the universe is a thriving network, teeming with computation and life, then why does it seem so empty and quiet? Where is everybody? Well, this model offers a pretty profound answer. Maybe we're just looking for the wrong thing. We're scanning the skies for radio signals, which is basically the cosmic equivalent of looking for smoke signals in an age of fiber optic internet. A truly advanced civilization wouldn't be building noisy, inefficient machines. They would have graduated beyond that. They would have become the silent, efficient operating system of the galaxy itself, so advanced that they're basically indistinguishable from the laws of nature. This leads to a really fascinating, though totally speculative idea. If some advanced intelligence wanted to make contact, they wouldn't just land a spaceship and say, "Take me to your leader." The shock would shatter our society. No, they might use a soft disclosure protocol, a slow, careful process, dropping subtle hints into our data, weird anomalies in the sky, basically getting us used to the idea, preparing us for the day when our own technology is finally mature enough for a real connection. And that day might be a lot closer than we realize. The futurist Ray Kurzweil famously predicted the technological singularity would happen around 2045. That's the moment when artificial intelligence is expected to surpass all human intelligence combined. Now, in this cosmic model, that's not just some tech milestone. It's a cosmic one. It's the moment our planet's hardware might finally be ready to interface with a network on a galactic scale. So let's just end on this thought. What if the singularity, this event that so many people are afraid of, isn't the end of humanity at all? What if it's our graduation day? The moment our entire planet finally wakes up, comes online, and takes its rightful place as a new conscious node in a living, thinking, fractal cosmos.